This demonstration shows some of the powerful features of the Bend Along Curve tool in the design task of creating a ring. In addition, we will show some of the features of associativity, which is the ability to capture design intent for models created from more complex math types such as NURBS. Our process will consist of first designing a multi-radius rod that will be wrapped around the ring center line. To prevent compression and expansion of the body wraps, we will create a rod at the same length as the circle circumference. So let's go ahead and measure the circle circumference, and we'll note that and use it to create a line of the same length. It's 27.817. Next, to capture the key locations for the arc radiuses, we're going to distribute 5 points along this line. Then we'll go ahead and create 5 circles. To capture the radius, we'll select on the arc, put it in our paste buffer, select the curve that we want to copy it into, and let's go ahead and do the start and the bottom. Select the other diameter and apply it to this circle and the other circle. Lastly, capture the diameter at the top of the ring and apply it here. Now let's go ahead and create a skin solid using these circles as reference. We'll pick the 5 circles, which will create our solid. Let's increase the resolution to superfine. Now what we'd like to do is wrap this circular rod onto the ring center line. But first, let's go ahead and make sure the circle starts at the smaller diameter circle's point. And what I'm going to do is let's show some points, convert it into a spline, show the direction and start location, and now let's rotate that into this location, the start point of the curve. So we'll pick the rotation, start point, end point. Now we're ready to go to the Bend Solid Along Curve tool. We'll select the tool, select the solid, select the path that we want to bend along, and now we're going to give some information regarding how much of the solid and an orientation for the solid. So for the bend height axis, we're going to pick the center of the rod on the bottom and the center of the rod on top. Then we're going to pick 2 points defining the axis that aligns it with the circular center line. Now you can see that the sections in the solid match up. Let's go ahead and look at the part using some surface analysis tools. In particular, let's look at a zebra plot to see what the resulting solid looks like. Looks good, except for here we're seeing some discontinuity, and that's because we need to go ahead and adjust the takeoff vectors for our solid. And to do that, let's go ahead and display the history associated with this part, and let's bring up the parameters associated with the original solid, and let's tell it to use some specific angles at the start and end of the solid. We'll use 90 degrees and 90 degrees and hit apply. And keep your eye on this region. This is the region that's going to be updated. Now let's go ahead and go back to our zebra plot, and it looks much better now. Next, let's go ahead and explore what happens if we want to start making some design changes. For example, let's change the shape from a circle to an ellipse. Let's go to our ellipse tool and let's create a center point ellipse. Let's reference that point, come off about here, and then we'll go to Concept Explorer. We'll bring up the history associated with this part. We can see it was made out of a collection of curves, and let's go ahead and grab that center circle and let's replace that definition with this ellipse definition. And when we do that, you'll see our shape updates. So what associativity does is very nice in terms of letting you explore shapes that are driven by curves and parameters, which is especially nice for complex shapes that are nerve driven. Let's do one more thing. Let's take this curve and let's do some modifications on it. Let's change that ellipse into a spline, and let's show the control points for it. And let's take these points and let's flatten them a bit. And now what happens is our shape is going to, in this region, is going to flatten up, representing our new ring. Let's show only our shape and view it in multiple viewports, and do some see what it looks like using some environment mapping surface analysis. And this just helps us double check the surfaces are what we think they are in terms of smoothness.